Hi everyone. So in this lecture we are going to study discrete probability distribution, and it's two type. One is binomial distribution and Poisson distribution. Proof related to binomial and Poisson in finding the mean, variance and standard deviation. So let's go for the proof. So the standard form of binomial distribution P of x is NCx p to the power x q to the power n minus x, and this can be tabulated whose sum of probability should always be 1. That we all know. The mandatory condition sum of probability should be 1, right? So which can be represented as p plus q whole power n is equal to 1. So these two results are highly important when we are finding the mean, variance and standard deviation. Starting with mean proof, mean is nothing but, since it's a discrete, we are using summation x is equal to 0 to n finite value, product of n into probability function. This we have applied in the problems also. So the representation of mean is mu is equal to, this summation of probability can be written as x is equal to 0 to n x into, for binomial distribution, please replace p of x as ncx p to the power x q to the power n minus x. The next step, we can apply the combination formula, combinatrix x is equal to 0 to n x into ncx can be written as n factorial by n minus x factorial into x factorial. The rest all term we are retaining the same q power x. We are going to express every term here, all the factorials in terms of n minus 1 and x minus 1. So what happens, x into n factorial can be written as up to n minus 1 term we are writing it. So n into n minus 1 factorial. Similarly denominator n minus 1, okay, minus x minus 1. Everything we are representing in terms of factorials, only the factorial terms. X factorial can be written as x into x minus 1 factorial. Next, we can write p to the power x as p to the power x minus 1. So it is p power 1 into p power x minus 1. You see, when base is same, powers it added, you get p power x back. Similarly, I am just going to represent q, n in terms of n minus 1, x in terms of x minus 1. Since we are converting everything to n minus 1 times, the limit instead of 0, it will be 1. Because when we put 0, it terminates to 0 factorial. So here we can cancel x and x. So now I am taking out the term which is not having factorial and which doesn't depends on summation. So I can take n and p, which is constant. So we are left out with n minus 1 factorial divided by n minus 1 minus x minus 1 factorial into x minus 1 factorial into p to the power x minus 1 q to the power n minus 1 minus x minus 1. So you can see the first term, this is an expansion of ncx, that is n factorial by n minus x factorial into x factorial. Instead of n, I have n minus 1 factorial. Instead of x, I have x minus 1. That's the only difference, right? So it becomes n minus 1 factorial by n minus 1 minus x minus 1 factorial into x factorial. So I hope this is clear. So you can write this as np. So I have just written in terms of ncx formula. Next we have np, okay, summation. You can clearly see this. You can see the summation, the terms completely of the form standard binomial distribution, but it is expressed in terms of n minus 1. Sum of all these terms should be p plus q whole power n minus 1. That we have already stated. If the sum of probability for this formula is q plus p power n, means instead of n we have n minus 1, instead of x we have x minus 1. So the sum of probability, because we have summation, so q plus p whole power n minus 1. We can represent it like that. So it is np, p plus q, happening plus non-happening, will be 1 whole power n minus 1, which I can still write it as np. So the mean of binomial distribution is always np. Thanks for watching.